Right then folks, taking a break from planetary astronomy just to show you this, one of my favourite things, the strangest objects in the universe. This is a rendering of the Andromeda Galaxy. It's obviously an animation, and right at the centre you'll see it's very bright because at the centre of pretty much every galaxy is a black hole. And here is a rendering of a black hole that's eating a star. It's a feeding black hole, and you can see there you've got several components. There's a disk around the black hole, that's called the accretion disk. There's a black hole in the middle, which is literally the shadow. So a black hole doesn't have an actual surface, it's just a shadow where light is rushing towards what's called a singularity. You can see it's pulling the star apart, and you can see there's a jet firing off into space. So to explain what's going on here, when a star reaches the end of its life, and it's a particularly massive star, this in particular here is a red giant, what happens is it starts to burn helium after it runs out of hydrogen, because it converts all the hydrogen to helium. And to cut a long story short, it's going to go through every element in the periodic table until it gets to iron. When it gets to iron, iron cannot be fused in the core of a star, so the iron builds up in the star and eventually suffocates the nuclear reaction taking place, and the star will blow itself to bits. And once it does, the outer layers of the star get blown into space, but the core of the star gets smashed inwards, and it gets smaller and more dense all the time until it creates something called a quantum singularity. That is physics speak, for your guess is as good as mine. That's where the laws of physics fail, because at the bottom of every black hole is a singularity, and we do not have the ability to describe that condition, and it can't be observed because a black hole is an object that has a gravitational field that is so powerful nothing can escape, not even light. So there's no way to observe a naked singularity. So when the black hole is born, this is what you get. You can see in this diagram there's a black hole at the centre, then you've got what's called the event horizon. The event horizon is the edge of the black hole, and as I explained earlier, it's not a surface, it's just a shadow. It's where light can no longer escape and light starts to rush to the bottom like a waterfall. Before you get to the event horizon, which is the point of no return, you'll approach, if you were to fall in you would approach a point called the photon sphere. The photon sphere is where light can't escape the black hole, but it doesn't yet fall in either, so it orbits the black hole. So if you're in the photon sphere, then you'd be able to see the back of your own head, because the light from the back of your head would go all the way around to the front and into your eyes, and you'd be able to see it. Those jets that you see are matter that is flung away from the black hole almost at the speed of light, just before it falls in, and that's because the accretion disk is spinning so fast due to the immense gravitational tides that it flings a lot of the matter away, and those jets can be as big as a galaxy. They are absolutely vast, and you can see there's the accretion disk. The accretion disk is matter falling into the black hole. If you were to fall into the black hole, once you pass the event horizon, you'll never get out, doesn't matter what you do, and you will fall towards the singularity forever. If you did fall in, if I was watching you fall in, first of all I couldn't do, because I couldn't live long enough to see it, because there is a differential between the time I experience and the time you experience, because the faster you travel, the slower time goes. It's called time dilation. So if you fell in, I would just watch you fall, and you would slowly get redder and redder and redder until you just faded from view. From your point of view, time would feel exactly the same. It would feel completely normal, and you wouldn't realise you'd fallen into the black hole until you'd passed the event horizon. And as you did fall in, interestingly, if you were looking towards the singularity, you would be able to see everything that ever fell in before you, and if you looked outwards, trying to look out of the black hole, you'd see everything that will ever fall in after you, and you'll fly towards the singularity. And as you do, well, not fly, you'll fall, and as you do, you will eventually undergo a process, and I'm not making this up, called spaghettification, where you will be stretched longer and longer and longer, and thinner and thinner and thinner over an infinite amount of time. You never reach the centre of the black hole, but unfortunately you don't survive it either. And there is some research to say that in a black hole, all things that can happen do happen, so you will end up being dead and alive at the same time. Weird, eh? They are the strangest and most destructive objects in the universe, but they are endlessly fascinating.